Assalamualaikum and salam sejahtera. So for today, I want to show you how to do the lab simulation for lab 3, the static coefficient of friction. So the first question for part A is, first we need to set the friction halfway and put the 50 kg box, and we set the force for 50 Newton. After we put the 50 Newton, the box is not in motion. So the friction force, static friction force is 50 Newton. The applied force is 50 Newton and sum of the force is 0. Now for the question number 2 for part A is when the box is in motion. After we increasing the force and when it reach to the 126 Newton, the box is start to move. So the friction force is 94 Newton, the applied force is 126 Newton, and the sum of the force is 32 Newton. Now for the last question for part A is when a 100 kg box in motion. First of all, we need to add the weight of the box to 100 kg, and then we apply force until the box is moving. So when the box is start to move, we can get the friction force for 188 Newton. So to find the speed, constant speed, we slowly reduce the applied force. When the force reach until the 188 Newton, the box is remain at the constant speed.
For part B, coefficient of static friction for table 1. Table 1 for angle 0 degree. For M2, adjust for 10 kilogram. And for M1, you have to adjust until the velocity increase and acceleration 0.08 meter per second square. For table 2, angle at 30 degree and the mass still not move, so acceleration at 0.02 meter per second square and velocity keep increasing. Table 3, given dry concrete on rubber, angle equal to 0 degree, and then coefficient of friction between M2 and surface at 1, and then put the M2 at 8 kilogram, and then run, and we have to find the value of M1 and see the value at acceleration 0.06 meter per second square and velocity keep increase. For table 4, dry concrete on rubber, angle at 30 degrees, coefficient of friction between M2 and surface at 1, M2 adjust at 6 kilogram, and then we run. We find the M1, which is okay, the object. Okay, the acceleration we got 0.07 meter per second square, and velocity keep increasing.